Well, I'm recording the homework video, literally 30 seconds from ending my last lesson video on this. So let's see how this rolls. So we were solving non-linear systems of equations, just two variable, keeping it simple, but we threw the additional piece of non-linear, and so that means sometimes they're not lines. And in our case, it's parabolas. Technically, this section also had some problems with circles, but I'm not going to do that right now. We're okay. So here we are. Solve the system by giraffing. Oh. I looked at these and I was like, oh, I'd rather solve this another way, but that's okay. I think I'm going to need that little, let's see, there's my inkwell. I'm going to need this little H formula. And so for the first equation, I'm going to get, oh dear, I'm turning on all sorts of features. H equals negative b over 2a. There we go. So for this top equation, H equals negative 8 over 2 times 1. Oh boy, now my tablet's acting up a little bit. And I'm not going to do the full explanation of this. You guys had a whole unit on graphing parabolas, and so we're speed running it. You know, we're speed running it. So there's H. To find K, I would then take this H and plug it back into the equation. So I'd have x squared plus 8 times x plus 18. Oh man, this is annoying. Come on, tablet. Stop being twitchy. So K is going to equal negative 4 plugged in for H here, right? So that's equal negative 4 all squared is 16 minus 32 plus 18. And so I get negative 16 plus 18 is 2. And so for my first parabola, I've got negative 4 up 2. There's the vertex. And then moved by my slopes, the slopes are positive, so it's just going to be regular old up 1 over 1, up 3 over 1. And the mirror versions of that. All right, tell you what, I'll put those dots in. That acceptable. Unacceptable. Boy. I'm recording this on a Friday, by the way. A little campfire with the kids tonight before this thunderstorm tornado warning comes through. Let's see. So here's the first parabola, but I've got to do it for the other one too. Ooh. Man, this would have been easier algebraically, but we'll roll with it. So I've got to do the same HK for this one now. And so, do I have space? Oh, look at all that. Wow, Mr. Waddy, you're so generous with your pixels. You gave yourself so much space there. So H equals the opposite of negative 16 over 2 times a negative 2 equals 16 over negative 4. Careful with your signs here. And H equals, well, you don't say. H equals negative 4. That's weird. It's the same x coordinate for the vertex. Now, it could be here, it could be here, it could be here, right? So I still actually don't even know how many solutions I have. I just happen to know that they have the same x coordinate of the vertex. All right, so K equals negative 2 times H squared minus 16H minus 3D, 30. And so I get negative 4 here, negative 4 there. Negative 4 all squared is positive 16. This multiplies to be positive 64. I'm assuming based on the window size I gave us, I've pre-planned this. And so hopefully it lands on this window. Oh yeah, it will. We're good. We're good. So let's see. 32 minus 30, I get, well, you don't say. It's the exact same vertex. And this one opens down, right? It's got an a value of negative 2. So my slopes would have been negative 2 times 1 over 1, negative 2 times 3 over 1, negative 2 times 5 over 1. Go check out my video on slopes of parabolas if you're not sure what's going on with those. And I'm not going to need to go that far. So from here, I would go down 2 over 1, down 6. And so, yeah, that's off this. But I've got enough to work with here. This one's like an upside down and skinnier parabola. But what do you see? They have a single intersection that happens to be their common vertex. It didn't have to be that, by the way. They could have been tangent at one of these points, so that would have been weird. And so negative 4 comma 2 is the common solution of both of those. Excellent. Good. So solving by graphing, it takes a little bit of work. I pre-gridded for you though, so you're welcome. Oh, look at this one. This one's not only pre-gridded, this is pre-graphed. Let's see. Oh, check out the scale. Oh man, don't let that fool you. And so this one is negative 2, negative 4. So that's negative 4 comma 0. And this point looks like over 1 up 5. And so, yeah, just read those intersections right off the graph. If they don't intersect, I know one of the problems, they don't intersect, and that means there's no solution. All right, solve the system by substitution. Hey, this one's already solved for y. Plug it in. I get 2x minus 3 equals plus 5x squared. Replace that with negative 3x minus 3. Stuff's got a lot going on here. All right, 2x minus 3. I can just drop those parentheses, I guess, eh? We'll subtract 2x from both sides. We'll add 3 to both sides. I was anticipating, because it's a quadratic, setting it equal to 0, solving by factoring or completing the square. We'll see what we get. I think I've got some good news on factoring, though, for us. Negative 5x plus 5x squared. Let's rearrange this whole thing. 5x squared minus 5x equals 0. Now, because there's no constant term, they conveniently had canceled. Factoring this is the best, because it's just greatest common factor. And so I'd have 5x times parentheses x minus 1 equals 0. Therefore, 5x equals 0, or x minus 1 equals 0. Oh, nice. You gave yourself space, Waddy. Well done. Man, my past self, sometimes he's an okay guy. Other times he's a jerk. Every wrong choice I've ever made in my whole life, my past self, tell you what. And so I get x equals 0, x equals 1. Now, what does that mean? That means that the solutions are two separate points. One in which x is 0, and one in which x is 1. There's a good sneeze there for you. Make that your ringtone, why don't you? So let's find the y coordinates that go with these. And so to find the y coordinate, I'm going to need to substitute. So y equals negative 3 times what? Minus 3? Well, 0. And so the first point is not an ellipse. Although you could do systems of equations with ellipses. I do have some Waddy Math videos from probably 7 years ago about equations of ellipses and intersections, and pretty good. You could go check it out. Negative 3 times 0 is 0 minus 3. I get y equals negative 3. So 0, negative 3 is one solution. And then the other one, y equals negative 3 times the what? Minus 3. And what is the what? I'm plugging in 1 this time. And so I'd have y equals negative 3 minus 3. Y equals... Y equals negative 3 minus 3 is negative 6. And so there's my two solutions. So on Big Ideas End, doing it online, you're literally just picking those 2 points. But you got to know how to do the algebra, friend. It's not just a matter of knowing coordinates. All right, last problem I'm doing for all y'all. Hey, look at this. I've got my... Oh, tell you what, I'm going to rearrange this. I'm actually just going to rewrite this one. I'm going to write negative 3x squared plus 2x minus 5 equals y. And the reason I rewrote it was I just wanted my x and constant and equals and y's lined up. So that works a little bit nicer. And I already drew this line under it, like you know what I'm doing. I know what I'm doing. We're using elimination. And what did I notice? I already noticed that the y's are opposites. And so I'm going to do a plus b. And so I'll have negative 3x squared. Negative x and 2x combine to be a single x. Negative 5 and 2 combine to be negative 3. The y's cancel out to equal 0. And, well, you don't say. I can make all of this positive. That can sometimes make my work a little easier. Or opposite, at least the coefficient. Now, I don't think this is factorable. 3 and 3 is 9. Factors of 9, 1 and 9, 3 and 3. None of those subtract to be 1. So it's a quadratic formula, friends. Non-factorable. And I'm going to hope that this has no solution because we don't want to plug in some square root expression in for x to solve for y. We're hoping not anyway. But let's keep going. X, oh, sorry. Let me sing here. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And let's simplify this. I get 1 minus 12, 36. Oh, good news. Good news, everyone. This is going to have imaginary solutions. So that's dandy for us. I get 1 plus or minus the square root of negative 35 all over 6. And since they are imaginary, this is going to mean no real solution. Boom. There you go. You're welcome. If it wasn't the case, then I would have had to take this and plug this entire thing in for like x to solve for y, which that equation actually wouldn't have been that bad. Just bleh. So anyways, thanks for watching, internet friends. Hope you all have a good day. Take care.